We don't have proof that we share the universe with other intelligent species, but many scientists believe that they are out there, proof or not. Perhaps extraterrestrials are watching us right now. Maybe they just sent us a message. Or maybe they have no idea that we're here, and they're talking among themselves. We'll never know the truth unless we listen. For half a century, the SETI project, the search for extraterrestrial intelligence, has done just that. SETI combs the sky with radio telescopes, hoping to hear alien transmissions. They're trying to wiretap ET, but they don't have his phone number. So, much as the CIA hunts for terrorist chatter, SETI tries to listen to everything out there. It's a daunting task. For starters, how can we tell the difference between a natural signal from the stars and an intelligent signal sent by strange alien beings? Dr. Jill Tarter is SETI's chief alien hunter.
If you'd like to listen to the cosmos, take an old-fashioned radio like this, an analog radio, and tune the radio between stations. And you hear that hiss? About 10% of that noise is actually coming from the cosmos. That's synchrotron radiation from the Milky Way galaxy.
SETI has combed the cosmic radio dial for 50 years. Most days it's quiet out there, but once in a great while, something exciting happens. In 1977, a SETI astronomer picked up a signal from the constellation Sagittarius. It lasted 72 seconds, the full duration the radio telescope was pointed at it. Going through the data, the scientists circled the signal and wrote, "Wow." The signal looked like the kind of engineered pulse that we expect will come from an alien civilization. The wow signal was a one-time event. Astronomers have returned to that part of space, looking for the signal, hoping for a repeat, but always coming away disappointed. To this day, there is still no explanation for what happened. In 1997, 20 years after the wow signal, SETI detected another signal from space, and Jill Tarter was there to witness it. At 6 o'clock in the morning at an observatory in West Virginia, Tarter and her team heard a mysterious sound coming from the Cetus constellation.
The signal showed up early one morning at the Green Bank National Radio Astronomy Observatory when we were using the 140-foot telescope there. I was actually at the telescope. We detected a signal, and it was clearly a manufactured signal. It wasn't just one tone on the radio dial. It was like a comb. Many different signals, all narrow, all separated by the same amount of frequency. Mother Nature wasn't doing that.
After years and years of listening, years and years of silence, Tarter wondered, is this it?
I was incredibly excited, and I was scheduled to finish up my observing shift in West Virginia at 8 o'clock and get on a plane and come home. When this started at 6 o'clock in the morning, I certainly wasn't going to get on any plane and leave the signal behind.
Tarter initiated a series of tests to verify the signal and find out if it was natural, man-made, or alien-made.
We moved the telescope off the star we were pointing on. The signal went away. We moved it back on the star. The signal was there. I thought, oh, I wonder if any of our other observations have seen that same kind of signal. But I was so excited that when I looked at the output, I didn't see that exactly what I was looking for was there. We had, at previous occasions, detected this signal with this frequency spacing. It turned out that it was a signal that was coming not from the direction that we were looking in, but a signal that was coming in our side lobes.
Tarter and her colleagues had made a mistake. The signal they detected was not alien. It came from a man-made space probe orbiting the sun called SOHO. SETI learned that to communicate in the cosmos it needed better technology. And now they're getting it. In Northern California, SETI is building hundreds of new devices to wiretap ET.
We're here in Northern California at the Hack Creek Radio Observatory. Right now, what we have is the Allen Telescope Array, an innovative new way to build a radio telescope, a large telescope out of small pieces.
By linking together a large number of small telescopes, the ATA gives astronomers a wide field of view, a radial picture 10 times the size of the full moon.
Today, we've got 42 of these dishes that are 20 feet across, and we're looking forward to expanding it till there are 350 of these small dishes. It may be just the right tool, finally.
The ATA gives SETI the ability to observe many more channels on the cosmic radio dial.
Now, because of technology, we simultaneously observe hundreds of millions of channels. And I look forward to the future when I can do billions of channels all at once. So technology has enabled the search on a scale that might finally be big enough to be able to detect something.
SETI scientists have wiretapped the stars for 50 years, but there's still no sign of extraterrestrial life. The great silence remains. And maybe that's not surprising.
SETI really is a needle in a haystack search without any guarantee that there's a needle out there.
Professor Paul Davies is a physicist and a SETI affiliate, but he's something of a heretic within the group.
The traditional approach to SETI is to scan the skies with a radio telescope in the hope of picking up a message from some alien civilization that's been deliberately beamed towards Earth. I don't think that's credible, and here's why. One of the big problems in this whole SETI business is the vast scale of things. The universe is really, really big. By human standards, it's just stupendously big. Imagine we get the smallest speck of dirt from the desert floor, and that represents the size of our solar system, right out to the orbit of Pluto. And then ask, how big is our galaxy? How far would you have to go to get to the far side of the Milky Way? And the answer is all the way to those hills right in the distance over there. And if you ask, how far do you have to go to get to the edge of the observable universe? Well, you'd need to go right out to the orbit of Mars.
It's often said that because our radio and television signals have beamed into space for 80 years now, aliens should have figured out that we're here and have sent us a message. But this argument overlooks a basic law of physics.
Another way of thinking about this is in terms of the speed of light, which travels at 186,000 miles every second. It takes light about 100,000 years to cross our galaxy, and it takes 13.7 billion years for it to cross the universe. Our first radio signals, which leaked out into space about 100 years ago, have gone about that far by comparison. Suppose there's a civilization 1,000 light years away, and that's actually pretty close by even SETI optimist standards. Well, they don't see Earth as it is today. They see it as it was 1,000 years ago. There were no radio telescopes here then, so it would make no sense for them to start sending messages to us until they knew that we were on the air. And they're not going to know we're on the air until our first radio messages reach them, and that's going to be in another 900 years.
Listening for signals from the stars is a long shot. So how can we do a better job of tracking down extraterrestrial life? As SETI monitors its cosmic wiretaps, another set of science detectives follow radical new leads. Leads that may take us right to ET's doorstep.